Hey guys, so these are the notes from Tuesday, January 25th. So we were talking about inverse functions, so I wanted to go over these with you. All right, just talking in general, what are inverses? Just not even mathematically, just what are inverses? And inverses are opposites. All right, so basically we're finding the opposite of a function, okay? So we're gonna write down our steps, and while we write down our steps, we're also gonna do an example as we do that. So we are going to find the inverse of 3x minus 5, okay? So my suggestion to you would be to print out these notes and then write them in as you watch the video, or just on your own paper, write down the steps and write out the problems. All right, so step one, first thing we're going to do is we are going to change our f of x to y. Okay, so we're taking it out of function notation and we're going to put it back into just with y. This could be g of x, h of x, k of x, whatever your function starts with, whatever the name of your function is, we want to get rid of that and make it y. So if my original is f of x equals 3x minus 5, then I'm going to change this to y equals 3x minus 5. Step 2, we are going to interchange your x and y. All right, so I'm going to take my x and my y and I'm going to flip-flop them. All right, so now I have y equals 3x minus 5. So by doing step 2, I'm going to flip these two. So now I have x equals 3y minus 5. All right, step 3, we're going to solve for y. So we want to get y all by itself. So this is just basic algebra work. Okay, using opposite operations. So I first want to get rid of this minus 5. So I'm going to add 5 to both sides to start. So I have x plus 5 equals 3y. Again, I'm trying to get y by itself. So I'm going to divide everything by 3. So those cancel. So then I'm left with x over 3 plus 5 divided by 3. Now, 5 divided by 3 does not divide evenly, so I'm just going to leave it as 5 over 3. If you can divide it evenly, then go ahead and do that. Equals y. Then our last step is then going to be to rewrite in inverse notation. So now we're going to bring back that function notation, but we're going to do it in our inverse. So we do f little -1 as if it's like its exponent, x, and then I'm going to write what I got for an answer. So now we're taking the y back out and we're putting it back into that function notation, but this -1 here tells me that this right here is going to be the inverse of my original function, which is up here. The -1, we do nothing mathematically, it's just designating that this is the inverse and this is the original. Now look, in the original, we multiplied by 3. Look down here, we're dividing by 3. Then up here, we subtracted 5, and notice now we're adding 5. So it's kind of like the opposites. That's why it's called inverses, because it's the opposite there. All right, we're going to go through 4 examples over here. Again, I would be writing these down and filling this in as I'm watching it. All right, so for the first one, again, I'm going to make this y equals -2x plus 6. Then step 2, I'm going to interchange my x and my y. So now it's x equals -2y plus 6. And now I want to solve for y. So I want y by itself. So I'm going to subtract both sides by 6. So x minus 6 equals -2y. To get y by itself, I'm going to divide by a -2. All right, so x divided by -2 is just x divided by -2 minus a 6 divided by -2. So notice there's a double negative here, so that turns to plus. 6 divided by 2 is 3, and that equals y. And then my last step is then to get rid of the y, right? And then write it using our inverse notation. So we have f of -1 of x equals x over -2 plus 3. Okay, just so you guys remember, when we have x over -2, that is the same thing as -x over 2, which is the same thing is the negative out in front. You can write it any of those ways. Those all three are the exact same thing. All right, looking at our second example. So in our second example, we now have division. All right, so again, we're going to make this y equals x plus 7 divided by 4. And now I'm going to flip-flop. So now I have x equals y plus 7 divided by 4. Now we have to get rid of this divide by 4 first. So the opposite of dividing is multiplying. So we're going to multiply both sides by 4. When we do that, all that happens on here on the right-hand side is that this denominator and this times 4 cancel each other out. We do absolutely nothing to the top. And then 4 times x is just 4x. So we end up with 4x equals y plus 7. Again, this denominator, this times 4, they just cancel each other out. So then I'm going to subtract 7 from both sides. And then I'm going to rewrite using my inverse notation. So there we go. Now, both of these examples are linear because we're only multiplying or dividing and adding or subtracting. Okay, so these are pretty straightforward. You're just using opposite operations to solve for y. All right, let's look at the bottom two. Now, notice on these, we have a square root and we have a squared. So these are going to be a little bit different. Still the same thing, still using opposite operations, all of that. So this is y equals 8 plus the square root of x. I'm going to flip-flop my x and y. All right, now, in order to handle the square root of y, I need it to be by itself. So I need to get rid of this 8. To move the 8, I'm going to subtract 8 from both sides. So x minus 8 equals the square root of y. The opposite of square root is going to be squared. So I'm going to square this side so that I can cancel out the square root sign. But whatever I do to one side, I've got to do to the other. So that side is squared. So the square root and the squared cancel each other out. So I'm left with just y. So now I have x minus 8 squared equals y. Now, this is not simplified. We have to go through and simplify it. Anytime we have an expression with adding or subtracting and we're squaring it, then it's going to be x minus 8 times x minus 8. And we are going to have to FOIL. All right, so first, x times x is x squared. X times negative 8 is negative 8x. Negative 8 times x is negative 8x. And negative 8 times negative 8 becomes a positive 64. We're going to combine the two terms in the middle. So I have x squared minus 16x plus 64. So because we had to square to get rid of the square root, you have to square this side. This is adding or subtracting squared means you have to FOIL. And then I'm going to write this using my inverse notation. Okay, so this is FOIL. Yes, it's a little bit more difficult, I understand, but you can still do this. You guys know how to FOIL. All right, now looking at if we start with an x squared. Okay, so I'm going to make y equals x squared plus 12, and then we're going to flip-flop these like that. All right, so I need y squared to be by itself. So to get rid of the plus 12, I'm going to subtract 12 from both sides. So x minus 12 equals, equals y squared. Now, to get rid of a squared, now over here, to get rid of square root, we took the square. To get rid of a square, we do the opposite, so we're going to take the square root. So we take the square root of both sides. The square root and the squared cancel each other out. So now I just have the square root of x minus 12 equals y. And there's nothing we can do to simplify that because we don't know what x is. So we can't do any simplifying, so we just leave it exactly like that. So then I write it using my inverse notation, and it would look like that. All right, so it's the problems that have the square root. There's a good chance that you're going to have to FOIL. The ones that start with x squared, those are actually pretty easy. You're just leaving it as a square root of x minus 12. All right, go ahead and flip it on the back, or if you're using your own paper, then you're just gonna write down some of these examples. I would highly recommend doing at least 2 from each column. That would be really smart, just to make sure you're doing it right, and then you can have Miss Carlock check it. I do want to look at 2 problems really quickly, just to make sure you understand. So we're going to look at a number 11 to start with. Okay, so on this one, again, we make this y equals the square root of x over 2, and then we flip-flop. Now, we have to get the square root of y by itself, so to get rid of a divide by 2, we are going to multiply by 2. So then this gives me 2x equals the square root of y. All right, to get rid of the square root, we're going to square it, which means we square this side. Now, on the other side, when we did this in our example, we had x minus 8 right here. Because it was adding or subtracting, then we had to use FOIL. But because this is being multiplied, we don't have to do FOIL. We're actually going to distribute the squared to the 2 things on the inside. All right, so now this is 2 squared times x squared equals y, because the square and square root cancel. 2 squared is 4. So then this ends up being 4x squared. And then if we write it using our inverse notation, it looks like that. Okay, so this one you did not have to FOIL because there's multiplying happening. All right, and then look at number 15. So we have y equals 2 square root of x, and then we change that to x equals 2 square root of y. We would divide both sides by 2 to start with. So now I have x divided by 2 equals the square root of y. To get rid of a square root, we're going to square. Now, just like up here on this one, when we were multiplying, we just distributed the squared. Same thing happens down here. You're just going to distribute the squared to the 2 things underneath. So we have x squared divided by 2 squared, which is going to be x squared divided by 4. And that's what your function, your inverse function, is going to end up being. So if we write it out, it would be x squared divided by 4. Okay, so just make sure you pay attention to those. 9 and 13, before you started that, you would want to distribute this, then start your inverse. 10 and 14, these are fractions that have been separated, but because they have the same denominator, you actually can put these together and then go from there and find your inverse. Okay, so I would highly suggest working a couple of these because you do have a quiz coming up soon over this stuff. So if you're not understanding, talk to Miss Carlock. Thanks, guys.